my experience and activity what we do to cater the small and medium scale, large medium scale industries by having an innovation and the CMS system. Next. Next. So this presentation offers about detailed information about the innovative and most reliable, affordable technology options, quality assurance data, installation technology, response time, repeatability, deviation, calibration and span check, zero and span drift check, and the data management and transmission system on a real-time basis. We also refer to the various testing and validation performance as per the EN 152673. In the recent times, the monitoring has become crucial. As you are aware, since last 3 days, we are talking about the various options available, various technology available, the reliability of the end data management. As you are aware, currently the entire world is very much focused on the source emission and ambient air quality. Especially in India, due to the stringent blow since last 4 or 5 years and the compliance that is introduced and considering. What I always consider is like we must work on the topical condition where we are located and where we are going to install the system. So the automated source pollutant emission monitoring has become mandatory in India as far as the country is concerned, and we are working on that. The objective, always says the objective is to have a special source emission monitoring and to meet the standards for that. And that too also with the real time to define, understand and measure performance efficiency of the installed pollution control device to meet the emission compliances. Various technology has been developed, starting from the critical, non-critical, or the advanced, non-advanced. Various technologies are there for real-time science application. The most important, to compare the periodic monitoring, I always believe that the purpose of the CMS only should not be related only to the pollution emission measurement. It has to be related to your process, your controlling device efficiency measurement. That will give you a good payback. As a businessman, when the industry installs the things, the purpose has to be defined as a process efficiency also for the pollution control device that you have installed. So, the past few years, many various gas and dust measurements technology with very specific, I underline this word, it's a gas handling devices are developed and used for the CMS source emission monitoring. Since the strict implementation of the source emission compliance in India, the major technocrats and people respecting the pollution boards are available. They are aware that the major problem we face in getting the compliance from the small, medium, and the large, medium type of industries. They are hesitating to install this system. There are 3 results what we understand in this kind of experience. One is a capex, there is a capital expenditure they have to put for the installation. Other is an operational cost, that is OPEX, and the third is subsequently it comes as an MANTAX, that is a maintenance expenditure. I'll be focusing on these 3 portions, and then we'll be talking how the innovation is. Thanks to present that the innovation of reliable, affordable, and the proven continuous source emission measurement technology, as per the monitoring certification schemes AMCERTs, as mentioned in EGN-M2, Environment Agency 2017. We adhere to that standards, the procedures, the applicable methodology to test the complete SAMs, So we currently, innovations what we have done is based on the very primarily the four technology we have used. For the one is the gas sensing, electrochemical sensors, differential optical, DOS, and VIR, and for oxygen, obviously zirconium oxide and EC also be used. We have used while testing as per the standards of M2. With all this technology, flue gas is being extracted. So we have tested the entire analysis we have done on the extraction-based technology for the gas handling and transfer to the sensor through very efficient gas sampling, handling, and filtration system. As I told earlier, the handling system is the most important part in the CEMS. Furtherly, while we're doing this all analysis, we have incorporated the pollutant gas with the pressure, temperature, velocity, flow measurement for normalization and compensation features. As you are aware that the US CPA 40 CFR 160 FNC methodology we have used, and so whenever we are producing, we produce the results. We are strictly producing on the real-time basis and milligram per normalized meter cube. The innovation of reliability with this technology is like system consists of gas measurement sensor, analyzer we can say, gas sampling, handling and conditioning system. As I mentioned, the pressure, temperature, velocity, flow measurement, zero spark drift validation. That is the most important thing we carry out before we do all this thing, presenting this technology team. We have incorporated remote and auto calibration facility as integrated into the system. Entire system's logic works with the PLC and given an HMI to have a very user-friendly operation of the system. The data-related data communication, we followed the IoT digital communication, as there is no interference of any algorithm in between. There is little information about the gas sensing electrochemical sensor. It's by operating with the gas, everybody knows this. I would like to narrate again, but if I share my experience of 27 years of using this technology of sensors, considered to be the most efficient, very fast responsive, and the most important part, which I'll come on the next slide, is 100% linear. So here in this thing, we can have a 2-point calibration. That's more than enough. And the stability of the linearity, we consider as more than 4 months to 6 months. Plus point is that you have a high range of SO2 measurement. You can go up to 5,000 ppm measurement without using, like that's the reason you don't need any dilution or anything to be done here. You can straightly choose that. Second part, somebody says that my emission levels are only 200 ppm, why I should go for 5,000, you can go for 1,000 ppm with the same sensor. So that the flexibility is being given here. The NOx we can go up to 3,000, again the same facility, flexibility is provided. As I mentioned, 100% linear, less zero and span rate, hence you can avoid the calibration as what normally in other technology you have to do every daily drift or zero testing. You have to do automatically daily. Here you can avoid that. And I'll show you that statistics what we have done in our laboratory by using this. The most concern is about the replacement, some of the component of the sensor or analyzer because they have a self-life. So here with this, we have considered the replacement of the consumable, of the sensor consumable is 15,000 to 18,000 hours. And this is being practically being monitored. It is better, it's more than that. In some cases, where you have a very clean application, it can go up to 20,000 also. I'm taking this figure as in the worst application. The most important is suitable with the tropical condition of our nation, is in India. The most essential, that there's every technology has its one essential part, is that it requires periodic air purging and efficient gas sampling, handling and conditioning system. If you have this essential offer, we have seen that the technology works very well. The other technology what you present is an ultraviolet diffusion optical absorption spectroscopy. The reason we worked on this was we will be able to get the actual NOx, that is an NO plus NO2. So we don't need to use any catalyst or a converter technology here. Again, here I'll have some benefits of that. Again, you can have a high measurement range. There's again the flexibility for the low measurement range also. As I mentioned, the NO and NO2 are separately measured here. So in the real time, you can have an NOx without having any other like catalyst or converter to be used. We have in laboratory, we have gone with I mentioned 100%, it comes to around 99 to 100% linearity as per the testing methodology of EM we have used. Hence, we can consider that it can be a 2-point calibration can be utilized here. As in the electrochemical sensors, as I mentioned, that the life of some replacement in the sensor, here we have a thermal ramp. The typical life comes to around 10,000 to 11,000 hours. You need to change. Again, we have seen and checked in the laboratory and on the field that we have made this equipment as suitable for the tropical condition of India. Essentials, again, same like periodic air purging, efficient gas sampling, handling and conditioning system has to be most perfect. I always say this, handling system. When we go BB to some people, they say the users, they say we want unattendable system. So that means when we install, we should not require to have a person to go for any maintenance. Friends, frankly speaking, I have not seen such any technology where you can have you can clap without two hands. So it is as good as responsibility of the supplier as well as the user. You have to understand the responsibility they have to take. That is a two-way things will work and the system will perform. Any technology will perform as such. We do have our own this special gas handling and sampling device, specially developed to cater the electrochemical gas sensor application. Very simple, nothing like you don't need any high-tech people to operate that or to maintain that. We have a 3 level of filtration starting from 5 to reaching to 0.1 micron for the moisture separation and the dust removal. So this benefit is that if you do have a better filtration and auto conditioning and auto purging, this helps the life of the sensor. The components which we use, definitely it's an SS216L is minimum we have used in that case. Yeah, forget to tell you one part. The last time was a tool-less maintenance. This is by sitting in our chamber, we just find out the new design. Because the major problem is in industry, the workers don't like to climb the ladder of 30 meters or 40 meters with a lot of tools. So we tried and developed a new design for the periodic maintenance of your sampling probe. The person has to go tool-less there and he can maintain the probe cleaning. So dry compressor is connected. Here I specially mentioned in this technology, we have seen that you don't need any instrument air or inert gas to be given for the gas handling and purging. You can use a simple compressor available in your factory, in industries, with the proper filtration, which should be a moisture-free. But moisture-free, we are going to talk about the dew point. It should not be a water molecule step. That was the concept. The benefit is there's the most efficient, affordable, user-friendly. It's an automatic gas handling filtration. You don't have to go periodically to drain the moisture collected at the bowl of the separation device. It is automatically taken care. So whenever we do the cleaning, your gas handling system is as good as a fresh one, right, after every cleaning. We incorporated, while testing all this thing, we also incorporated auto calibration methodology and remote calibration. We made an in-house in our R&D department the zip for that, connecting not less than 6 various gas cylinders with controlling with the PLC and synchronized with the CEM system which we developed. And so automatically we find that how the auto and the remote calibration functioning is happening and the results are coming to that. As I told you earlier, that electromechanical technology will have a very less zero and span drift, and gives a very, you don't need to do a lot of calibration and functioning there. And reduce the operational maintenance cost is reduced. Now, to validate or to test the performance of this technology, we follow the zero span drift validation. That is the most important we should do at the site. We have done this, and this is what we follow in the 12.3, like 15267 standards. Absolutely, the first 6 months, we just studied the entire standard, formulated into an Excel sheet, while considering all the formulas, getting the virtual result and putting that. And then we converted the entire thing into a software. So currently, my entire product, what we do test, is working on the software. The zero, span and drift are more stable for a long time and help users to spend less on operational cost and maintenance. Entire focus on doing it on an affordable part here. So this is one lab test of AMS as per the standards. This is as per the 15267 we done for the response time, and we got for 0.42. This is what we achieved. This is only one Excel sheet I am presenting you, just for an idea how the methodology we have adopted in-house in our R&D department to check the response time with the electrochemical sensor and the gas handling, automated gas handling device. Further, we go with the repeatability standards deviation at span point here. Again, we got like deviation at span point in percentage of full scale comes to 0.05. We are still trying to get better here. We are working, it's not the only sensing part, it's your electronics works you have to be electronics very effective there, which you are generating as an analyzer. So this was in-house, is more than 6 months data we have. I'm presenting here is one of the Excel sheet which you got tested. The repeatability started emission at 0 point. Here we could achieve at 0.02. We could not go much lower into this, frankly speaking, because almost like 6 months, 8 months we work on this, all type of electronics and with the gas handling device, and we try to minimize this all. But ultimately, in this case, we could achieve this was the lowest so far. It's not that we have stopped doing, but we have done a lot of things for doing this. Why we are doing all this thing is the reason, like, and a lot of analyzer technology you need an everyday zeroing. Every day you need to drift checking or compensating the drift. This we are avoiding, because whenever you are doing this, you are consuming the gas, and that's a cost for the industry. So this is a system which we use for conducting this test for acetic gas of 2000 ppm, range we built, and the sensor was a gas sensing electrochemical sensor. Certified concentration we use of 1020, So we consider the 90% as per the Indian standard was time 1A, flow rate was kept at 1 LPM. And the rise time, the logging time, response time, this was all we measured as per the standard procedures mentioned into that. So as per the standard, compliance ensures, this ensures why we are doing this, why we are presenting this to you, to get ensured that you develop the confidence that this innovative technology can be credibility at a substantial reasonable cost of ownership and at par with the other measurement technology. The last part, which comes to as a real-time data acquisition management, everybody is doing now. We adopted this methodology 3.5 years back, considering looking to the future, the trend going to come in the industrial market in the data communication, especially in India. With the views this gives and benefit to get a very digitalize the remote calibration procedures, and you can access the entire system remotely from any part of the world. So there is no external computer required device. So since last 3.5 years, our data is straight transferred from the analyzer to the server at the regulatory body. No software required, so list transfer and manipulations or any offset settings or like that. And further, it reduces the investment and maintenance costs. Conclusion on the last case. This innovative technology, components, configuration, and methodology helps industry to opt benefit of affordable solution confidently. That's the most underlying word here. You can trust, you can really be confident what you are measuring, and you can rely on the data what you are getting. This innovative science system operates at very low electricity power consumption, hence helping saving the carbon generation and ensure greener environment. That is an indirect benefit. When I was talking about the CapEx, OpEx, and MedEx, so this comes under the OpEx. By doing this, we are further servicing, giving a service to the environment by reducing this cost. We as a technocrat are always responsible to develop and provide affordable CEM system solution based on tropical conditions. The underlying word I use is tropical condition. Hence, become more reachable to all sides of industries and give them opportunity to contribute for pollution control and environment conservation for greener earth. This is what our aim was, to serve the people. It's not that the small industry doesn't want to control or monitor the environment, but we are this technology making to reach there. He wished that, okay, let me have this technology and laser and contribute for the greener world. Thank you so much. Giving a big thank you to the chair and the committee of this organization for giving this opportunity. Thank you so much.